In today's episode, you will learn how to make your own ESP8266 Wi-Fi module based home or office automation project along with a feedback system using an application on your Android cell phone. Then watch this tutorial from start to the very end, because at the end of this tutorial you will be able to make your own automation system using ESP8266 Wi-Fi module. This tutorial will cover the following. Number 1. ESP8266 Wi-Fi module software or firmware update. Number 2. Use of AT commands. Number 3. Complete project circuit diagram. Number 4. Interfacing. Number 5. Programming, and finally number 6. Testing. Let's get started. So my friends, this is the ESP8266 Wi-Fi module, which is most commonly used throughout the world for automation purposes. With the help of this module, which is ESP8266, you can control and monitor any electrical device. It may be a bulb, fan, motor, robot, car, etc, etc, etc. You can monitor your sensors wirelessly from anywhere around the world. In simple words, we can say that this tiny module, which is ESP8266, has infinite uses. It can be used in millions and billions of projects in different styles. So before we start using this Wi-Fi module in any project, first let me tell you about its pin also. Starting with this pin. This is the VCC, and it should be connected with 3.3 volts of the Arduino or Mega. So make sure that you don't apply voltages greater than 3.3 volts, as it can damage this Wi-Fi module. Then this second one is the reset, and this one is the CH_PD, and this one is the TX, which is a transmit pin of the Wi-Fi module. Then this one is the ground, and it should be connected with the ground pin of the Arduino or Mega. And this one is the GPIO1, and this is the GPIO0, and this is the RX, the receive pin of the Wi-Fi module. So now my friends, that you have an idea about its pins. Now before you can use this in a project, first of all we have to update a software. So how to do that actually? Now first of all, as you can see on the screen, first of all, upload this simple sketch, which consists of the white setup and the white loop. And as you can see, the code is just uploaded. So my friends, now to update the program, we have to make some connections, and for that we will have to connect the TX pin of the Wi-Fi module with the TX of the Arduino, and the RX of the Wi-Fi module with the RX of the Arduino. Connect the RST of the Arduino with the ground, as you can see. So it will actually bypass the ATmega328 microcontroller. And then connect the VCC, which is the 3.3 volt pin of the Wi-Fi module with the 3.3 volts of the Arduino, and also connect the PD pin of the Wi-Fi module, which is this one, the CH_PD. Also connect this one with 3.3 volts of the Arduino, and connect the ground of the Wi-Fi module with the ground of the Arduino. So we make these connections, and make sure that you connect the GPIO pin of the Wi-Fi module, which is this one, the GPIO0, with the ground of the Arduino. So these are the connections, and now let's update the software. I have already downloaded that software, so make sure that you download this software, which is the ESP826 Flasher, and this is 0.9.2.4. Now click on this, the exe file, click on the bin, and now select this one, the V0.9.2.4, the AT firmware. So open this, and my Arduino is installed on COM5, so click over here, and if you want, you can also confirm this from here, tools, and over here you can see it's COM5. Okay, so now click on the download, and now you can see it's just started. And over here you can also see that the LED is blinking. So at 99 you will get an error, but just don't worry about this. Okay, so now the firmware is updated, and now let's check the AT commands. So for that, first of all, we'll have to remove Arduino Uno. Just disconnect that and disconnect the GPIO 0. So the wire which is connected with the GPIO 0, simply disconnect this. Okay, so now it's disconnected. Okay, so now connect this. Okay, and now click on the serial monitor. So once again, I want to tell you that make sure that you disconnect the GPIO 0 pin from the ground. So I've already disconnected that, and rest of the wire are as same as such. So the CH_PD is connected with 3.3 volt, the VCC is connected with 3.3 volt, and the RX is connected with the RX pin of the Arduino, and the TX of the Wi-Fi module is connected with TX of the Arduino, and the RST of the Arduino is connected with the ground. So now the serial monitor is open, and let's type a command which is the AT and AT plus RST. So it's working great. So now we are done with the software updating, and as you can see on the screen, the AT commands are working. So now this Wi-Fi module is ready. So friends, this is the complete circuit diagram of the ESP8266 Wi-Fi module based home or office automation system with feedback. And let's start with the ESP8266 Wi-Fi module and its pinouts. As you can see over here, the VCC of the Wi-Fi module is connected with 3.3 volts of the Arduino, and also the CH_PD is connected with 3.3 volts of the Arduino. You can simply connect these two wires and take one wire and connect it with 3.3 volts of the Arduino. As you can see, the RST, the reset pin of the Wi-Fi module, is not connected with the Arduino, and the TX pin of this Wi-Fi module is connected with pin 2 of the Arduino, and the RX pin of the Wi-Fi module is connected with pin 3 of the Arduino. The GPIO pins are not used, and the ground pin of the ESP8266 Wi-Fi module is connected with the ground of the Arduino Uno. So as you know guys, that the ESP8266 Wi-Fi module communicates with the Arduino through serial communication, so that's why we are connecting the TX and RX with pin 2 and 3 of the Arduino. Well, my friends, as you know that the Arduino Uno has only one serial port, and that is on pin number 0 and pin number 1. So as I always recommend that never use pin 0 and 1 for the serial communication, because we always use those two pins for the serial debugging. So I recommend that you should use any two otherwise. So that's why I'm using pin number 2 and 3. So you can make multiple serial ports using the software serial library. So if you want to learn in detail how to use a software serial to make multiple ports, you can watch my tutorial on that. So I'll be using a serial port on pin number 2 and pin number 3. If you want, you can define any other two pins like pin number 7 and 8 or any other two pins. So that's how the ESP8266 module is connected with the Arduino Uno. And let's talk about the relay module. Well, actually I will be connecting a 7-channel relay module with the Arduino Uno, but I will use only 5 of relays, so 1 to 5. And if you look at the designing over here, you can see it's a 12 volt relay, so that's why a 12 volt is connected. And this is the relay coil pins, pin number 1 and 2. So, and the other side of the relay coil is connected with the collector of the 2N222 transistor, and the emitter is connected with the ground. So as the 2N222 NPN transistor, it's a BJT and it's a current control device, so that's why a 10k resistor is connected over here to limit the current, and then it is connected to pin number 9. So as I'll be using 5 relays, so that's why pin number 9 to pin number 13, the 5 relays will be connected. If you want to learn how to make a relay driver circuit and how the calculations are performed, then you can watch my tutorial on the relay driver circuit design calculation. It will really help you. When you watch the tutorial, then you will be able to design your own driver circuit for the solenoid valves and for relays, like for the DBT relay, the SPG relay. So do watch the tutorial. Okay, so that's it. It's the complete circuit diagram, and we'll be doing the interfacing as per this circuit diagram. So now let's start with the circuit interfacing. So friends, as you can see on the screen, all the components are interfaced with the Arduino Uno as per the circuit diagram. This is the ESP8266 Wi-Fi module. We just updated the firmware, and while holding the ESP8266 in this way, now this is the VCC, and as you can see, this wire, these two wires, this is connected with 3.3 volt of the Arduino, and this another wire which is coming from here is connected with the ch_PD, and the other wire which is the TX, this one, the topmost, this wire is a TX, and it is connected with pin 2 of the Arduino, and similarly the RX of the ESP8266 is connected with pin 3 of the Arduino. So all the connections are 100% as per the circuit diagram, and the ground of the ESP8266 is connected with the ground of the Arduino Uno, and the RST and the GPIO pins are not connected. This is a 7-channel relay module. Currently I'm using only 5 relays, and these relays are connected with pin 9, 10, 11, 12 and 13. So if you want, you can use 7 relays, or even if you want, you can use more relays as per your requirements. This is the DC socket, and over here we will connect 12 volt power supply for the relays. The relays I'm using are SP80 type, stands for a single pole double throw, and it needs 12 volt. These are the terminal blocks with which we can connect AC or DC loads, and these are the 2N2222 NPN transistor, a 10K resistor, and over here we have a diodes, so which are used for the back EMF protection. So the circuit connections are very easy, the interfacing is really easy. If you want, you can make your own relay modules. Just watch my tutorial on how to design your PCB or in Soft Eagle, so you can make one at home, or if you want, you can purchase this online. So the interfacing is simple, and now we will discuss the programming. So my friends, this is the code written for the home or office automation using ESP8266 Wi-Fi module, and we start with the hash include software serial.h. As in the circuit designing, I explained that we will be using pin 2 and 3 of the Arduino Uno for the ESP8266, so that's why we will be needing a software serial library by defining our own serial port. So the 2 and 3 means 2 is the RX and 3 is the TX. So this means that you need to connect the TX pin of the ESP to the Arduino's pin 2 and the RX pin of the ESP to the Arduino's pin 3. And now these are the 5 relays. The integer relay 1 equals to 9. Well, actually I selected relay 1, relay 2, relay 3. If you want, you can give it any name, and it should follow some rules like numbers at the beginning of the variable names are not allowed, spaces are not allowed in the variable names, and then there are 5 flags which I'll be using with these relays to stop the unnecessary repetition of code. Now friends, as you know that every Mega and Arduino program has at least 2 functions, and those are the white setup and white loop. So the white setup executes only one time, and then we start with serial.begin, which is 11, 52 and 00, and the ESP8266.begin, which is the baud rate, and it is 11, 52 and 00. Your ESP baud rate might be different. So now pin mode relay 1 is the output, so as these relays will be used for controlling the loads. The load may be AC or DC, so which are the output devices, so that's why output, and we keep all the relays off by default. And then we start with the AD command. So send command, which is the AD plus RST, which is for the reset, and this actually reset the module, and then there's a delay of 200 milliseconds. So, and then send command AT plus CWMOGE equals to 2, and which configures as the access point, and then there is a delay of 200. And now I've commented these two lines because in the upcoming tutorial I will tell you how you can use your ESP8266 Wi-Fi module to send your sensors data to an email, or how you can use this to build a security system, so whenever someone crosses a laser or a PIR sensor motion, then an email will be generated and it will send you to your email inbox. So send command 80+C IFSR, and this is used to get the IP address. When we will upload this program in Arduino Unit, then we'll show you how you can get an IP address. So delay 200, and then send command 80+C IPMUX equals to 1 configures for the multiple connections, and then again there is a delay of 200 milliseconds. So don't worry about these delays which I'm using over here, because this function will only be executed only one time when the control starts, and then these instructions are not executed again. Then we start with a while loop, and this is a loop which runs infinite time. So character pin number equals to 0. This is a variable name of the type character, and currently it has 0. And character second number equals to 0. So if ESP8266 dot available, check if the ESP has something like it has data, then what to do? Character connection ID equals to 0, and ESP, this is a read function, and subtract 48 because the read function returns the ASCII decimal value, and 0, the first decimal number, starts at 48. And then the ESP8266.find, we actually search for this one, advance the cursor to pin equals this, and character pin number equals to, then we read the ESP, this is the function, and get first number, i.e. if the pin number 13, then the first number is 1. In serial.print ln and pin number, and serial.print and pin number. So as you can see over here, we are actually using the Arduino default serial port for the debugging purposes. So this way we can check what's actually happening. So that's why I always recommend that you should never use the Arduino default serial port for connecting any module. Okay, so character send number equals to this, then we read it, we read, and serial.print second number, and then we just send it to serial monitor, and then string content, it's a variable of the type string, and currently this is empty. And now we start with the relay 1. So if pin number equals 1, and the second number equals 1, and the flag 1 equals to 0. So what does it mean actually 1 I'm actually sending 11 from the Android application, which I will show you in a couple of minutes. So it will check the number which I'm sending from the Android application, and also check the flag. So if the flag is 0, it means if the relay is off, then what to do? Digital write relay 1 high. So if you have received 11 and the flag 1 is 0, then turn on the load which is connected to relay 1, and content equals to relay 1 is on, which is a feedback message to the Android application. So when I will be pressing a button on the Android application, it will send 11 to the ESP module, then the ESP module receives that and gives it to the Arduino Uno. The Arduino Uno checks this. If the condition is satisfied, then it will execute these instructions, and a feedback message will be sent to the Android application that the relay number 1 is on, and then the flag 1 equals to 1. So then this flag 1 changes from 0 to 1. So if you want to learn in detail how to use flags in your Arduino programming, then watch my tutorial on how to use flags in Arduino. It will really help you. And so the next time when this load is on, and the next time you press the same button on the Android application, then these instructions will not be executed because this flag is already changed. So if number 1 and 8, so I'm using 1 and 8 to turn off the relay 1. So if the flag 1 equals 1, which is already changed to 1, Then this time it will turn off the relay and a feedback message will be sent to the Android application. And similarly for the rest of the relays, only the pin numbers are different and the flags are different. So I will provide a link in the description, and you can simply download this code from my Blogger page. And so the programming is exactly same for all the relays. And then there is a feedback message. For example, let's just imagine that 2 or 3 hours ago you just turn on some loads, and now you have completely forgotten that which loads are on and which loads are off. So you can simply press a button on the Android application which will send a message of 55, a number which is 55 to the ESP, to the Arduino, and it will send you a feedback message which will have info of all the loads which are connected with the Arduino. So first of all, if it will check the relay number 1. If digital relay 1, so it checks if the relay 1 is high. What it will do, it will content plus equals to relay 1 on, or if it's off, then it will add this to the content, and then it checks the relay 2. So if it is on or off, it will add that content. It will make a complete message consisting information of all the 5 relays, and it will make that message and send it to you. Then the send HTTP response, which is the connection ID and the content which we just created, and the make close connection. So string close command 80 plus CIP close equals to this, and closes the TCP UDP SSL connection. And so these are just simple instructions. And then string. So if you want, you can read all the 80 commands. So just let me show you. You can simply download this PDF file. So over here you can see that 80 plus CIP closes the TCP UDP SSL connection and all the information it has. So you can give it a read. You can simply download this from the internet. Just make a search in the Google with the 80 command for the ESP, or you can write this for a -SP, and you can just download this PDF file. So before you use or before you start the programming, so do read these 80 commands so that you can have an idea, and you can also implement those 80 commands which I showed you in the beginning, how to implement the 80 commands. So now this is a string send data, which is a function of the type string, and it takes 3 arguments: the boolean, the debug, the timeout, and the command. So string response, this is empty, there is nothing, and the integer data size is equal to command dot length, which is a function. Character data and data site, command dot to character, then we just convert that into character data and the data size, and then write, okay, and send the read character to this. So fdebug, and a long integer time mils, which is just for checking the timeout, and while esp.available debug. Then this is the white send HTTP response character connection ID and the string consent. So which is like simple. You can give it a read. Then this is the send CIP data, character connection ID, string data, and again this is an 80 command which you can just study like using the 80 commands. Over here you can see. Let's check for this one. So 80. CIP send, so which sends the data. So that's it. The programming is simple, and you can download this code from my Blogger page. I will provide a link in the description. And now we will upload this program in Arduino, and then we will see this project in action. So now, my friends, the Arduino is connected, as you can see over here on COM5, and let's upload this. So now the code is uploaded, and first of all, let's check the serial monitor whether it's working or not. So now you can see Now this is our IP address, the 192.168.4.1, and it's on port 80. So I will use this and this one in my Android application, and our server is ready. Okay, so now I will show you this project in action. So my friends, as you can see on the screen, the ESP8266 Wi-Fi module is on, the Arduino is on. I have connected a 12-volt supply over here for the relay module and a 12-volt supply with the Arduino Uno, and now it's ready. So this is the Android application designed for the home or office automation using the ESP8266. So over here you can see I've entered the IP address, which is 192.168.4.1, which I showed you in the Arduino programming. So, and this is the port number 80, and currently this application can control 5 devices. Now device may be AC or DC, and this is the feedback button. So let's start with the device number 5. As the device number 5 is connected with pin number 13, so you can also see the LED which is connected on pin number 13. So when it turns on or turns off, so for that purpose I have connected a DMM in the continuity mode. So I've connected these 2 wires, so when the relay which is connected with pin number 13 turns on, so you will be able to hear the beep sound. So this is the application, and over here you can see it is connected with the Wi-Fi module currently. Okay, so now let's click this 5, and you can see the LED which is on pin number 13 is on, and you can also hear the beep sound, and you can also watch the feedback on the cell phone. Now let's turn this off. You can see it's also sending me a feedback that the relay 5 is now off. So let's, for example, ask for the feedback, and you can see it's telling me that the relay number 1, 2, 3, 4 and 5, all the relays are off. So you can use a feedback at any time if you have forgotten that which loads are on or which loads are off. Let's, for example, turn this 2. So if you don't get the feedback system, it means that the command is not implemented. So let's try again. You can see this time it's implemented and the relay 2 is on. So from the feedback we know that which load is on and which load is off. So now let's do it for the device number 5. So as you can see it's on. So currently we have turned on 2 devices, and if later on you forgot, then you can just simply confirm using this feedback button. And now from here you can see that the relay 1 is off, relay 2 is on, and the relay 5 is on. So now you can turn device 5, now it's off, and you can also turn off device 2. So as you can see we didn't get any feedback, so it means that the command is not implemented. So let's try again. And now you can see it's turned off, and now let's ask for the feedback again. And now you can see that all the loads are off, all the relays are off. So my friends, I hope you liked today's episode. If you have any questions regarding this project or any other project, simply let me know in a comment. And next time I will make a tutorial on how you can send your sensors data to an email, or how you can use this ESP8266 Wi-Fi module to implement a security system. So do subscribe to my channel, and see you in next episode.